Let us see few examples. Find the coordinates of the point which divides the join of -1, 7, and 4, -3, in the ratio 2:3. Let us see the answer now. Let P, X, Y, be the required point. Using the section formula, we have P, X, Y, equals M1x2 plus M2x1, is divided by M1 plus M2, M1y2 plus M2y1, is divided by M1 plus M2. Consider A as -1, 7, B as 4, -3, and M1 as 2, and M2 as 3. On substituting the values of x1, x2, y1, y2, m1 and m2 in section formula, we have x equals 2 into 4, plus 3 into -1, is divided by 2 plus 3. Remember that, here x1 equals -1, x2 equals 4, y1 equals 7, y2 equals -3, and m1 is to m2 equals 2:3. This implies that x equals 8 minus 3 is divided by 5. This implies that x equals 5 is divided by 5. Therefore x equals 1. Y equals 2 into -3 plus 3 into 7 is divided by 2 plus 3. Y equals -6 plus 21 is divided by 5. Y equals 15 is divided by 5. Y equals 3. Therefore, 1, 3, is the point which divides the join of -1, 7, and 4, -3, in the ratio 2:3. Let us see another example. Find the coordinates of the points of trisection of the line segment joining 4, -1, and -2, -3. Let us see the answer. Let P, x1, y1, and Q, x2, y2, are the points of trisection of the line segment joining the given points, that is, a P equals PQ equals QB. If a point P divides A, B internally in the ratio 1:2, and point Q divides A, B internally in the ratio 2:1, then P and Q are called points of trisection. Therefore, the point P divides AB internally in the ratio 1:2, and point Q divides AB internally in the ratio 2:1. We have point P dividing A, B internally in the ratio 1:2. Using section formula, P of x, y, equals M1x2 plus M2x1, is divided by M1 plus M2, M1y2 plus M2y1, is divided by M1 plus M2. P of x1, y1, divides A, 4, 1, B, -2, -3, in 1:2 ratio then. Here x1 equals 4, x2 equals -2, y1 equals 1, y2 equals -3, and m1 is to m2 equals 1:2. On substituting the values, we have x1 equals 1 into -2 plus 2 into 4 is divided by 1 plus 2. This implies that x1 equals -2 plus 8 is divided by 3. This implies that x1 equals 2. Therefore x1 equals 2. y1 equals 1 into -3 plus 2 into -1 is divided by 1 plus 2. y1 equals -3 minus 2 is divided by 3. y1 equals -5 is divided by 3. Therefore P, x1, y1, equals 2, -5 is divided by 3. Consider point Q dividing AB internally in the ratio 2:1. Therefore we have Q, x2, y2, divides A, 4, 1, B, -2, -3, in 2:1 ratio, then. Using section formula, that is, P of x, y, equals M1x2 plus M2x1, is divided by M1 plus M2, M1y2 plus M2y1, is divided by M1 plus M2. We can find Q, x2, y2. On substituting the values, we have x2 equals 2 into -2 plus 1 into 4 is divided by 2 plus 1. This implies that x2 equals minus 4 plus 4 is divided by 3. This implies that x2 equals 0. Therefore x2 equals 0. y2 equals 2 into minus 3 plus 1 into minus 1 is divided by 2 plus 1. This implies that y2 equals minus 6 minus 1 is divided by 3. This implies that y2 equals minus 7 is divided by 3. Therefore y2 equals 0. Therefore the points of intersection of the line segment joining 4, minus 1, and minus 2, minus 3, are P of 2, minus 5 is divided by 3, and Q of 0, minus 7 is divided by 3.